51, we have a block of mass, 3.7 kilograms on a frictionless plane, inclined at an angle of 30 degrees. It's connected by a cord over a massless frictionless pulley to a second block, 2.3 kilograms, hanging vertically. What are the magnitude of the acceleration of each block, the direction of the acceleration of the hanging block, and the tension in the cord? So first of all, what are we going to do? We're going to draw force of gravity on both of these. I'm just using 10 for gravity. We're going to break this one on the thing in the components that's perpendicular and parallel to the ramp. In addition, we have the tension, both in the rope here and over here. Those two tensions are going to be equal. How do we find the acceleration? We just have to figure out the net force. Normal force in this case would be 32 newtons. Frictionless, no other forces. What's our net force? Well, we've got the 23 trying to accelerate this thing this direction, the 18.5 going the other way. Net force, just the difference between those, equals the mass that's being accelerated, both of those together, times the acceleration, and you'll discover that it's accelerating 0.75 meters per second. Don't know why I have an extra zero on there, sorry. And that's going to be in this direction. Why? How do I know that? Because this 23 is going to be larger than the 18.5. It's going to accelerate up the ramp. What direction is this hanging mass accelerating? The answer is it is accelerating downward. Now, to find the tension, we need to look at one of the two masses by itself, either the one on the ramp or the one hanging. I'm going to look at the one that's hanging here. How do I do this? F equals ma. Net force acting on it, we know the 23 is acting downward, tension's acting upward. Net force is going to be the larger minus the smaller, equals the mass times the acceleration. You could also do it with positive, negative signs. In this case, you'll discover the tension's a little bit less than the force of gravity. It's 21.3 newtons. Hopefully that makes sense. Good luck.